Good evening, ladies and gentlemen. I was told not to speak in Dutch, so I guess there's some people who still need to learn Dutch a little bit. Usually I don't listen to that, but because Spilberg is a nice company, I follow their orders. But I will use some Dutch words in between to cheat you a little bit. Yeah, I've been invited by Spilberg, so I don't know really about the audience in order to affect, because usually I have a presentation that I adapt a little bit to the audience. I know you're all kind of embedded software engineers, is that correct? I don't hear yes. Software, is that correct? Okay. Yeah, it's a silent room. I'm saying this in the beginning because I've been doing this kind of presentations also for my work and presenting technology in other countries like in China and Korea and Taiwan. And it's always interesting to learn because people are very silent and they don't say anything. So at the end of the talk, you think, did they understand a bit of it? And then you get the first question, one question, and you understand they understood the whole talk in detail. So sometimes you have to be careful. What I will do today is give you a presentation, and I hope it will be half an hour, 30 minutes max, what was being told, but please stop me if I'm skipping time, is to tell you a little bit, not about IoT directly, but about technology that a Dutch company have developed, and in the kitchens that we've looked with that technology from all kind of companies worldwide, try to understand a bit of all kind of issues related to software development, software engineering, licensing, and all kind of issues, and also try to look at the future, even when IoT is there, it's not there yet. When it's really there, what will come beyond? So I try to speculate a little bit on that later. But that's the idea. But I will go actually very randomly through all kind of issues, so there's not a real logical thing in this whole story. Please interrupt me if you have any questions or things. If it's too long, we can postpone it to later. First, I have a sheet about myself to give you an idea, because I used to be an engineer. I still try to be an engineer now and then, but it's hard if you have a lot of specialists around you. And I've been fortunate to work for a nice small company where I've been able to grow from engineer doing everything, technical marketing and sales, because nobody else was doing it, and actually been traveling around the world selling very complex technologies. And it's a very, very funny and nice story sometimes. So I'd like to share some of the things I learned also from the perspective of IoT and that. And I just joke, you know, I have 5 full passports. I actually, if you go to China a lot, you get 2 pages for each time you go there. You don't get a multiple entry visum, so it's full very quickly. The company I represent and also present this for tonight is ACE. And yeah, I know one person who knows ACE, and of course Spilberg knows ACE a little bit. But we're one of the oldest, I could say, really IT companies in the Netherlands. And high-tech, small, medium enterprise, and we've been entrepreneurial in many things. So we were the first to port Unix commercially in the world on the 68000 processor in 1981. We've done what now everybody knows about open systems and Unix. We laid the foundation at the time by also standardizing that. And I skipped many other things, parallel systems. We just talked about parallel architectures like NVIDIA. We've done all of that as well, but it's like the major thing I want to talk today is one of our flagship products. It's the COSY compiler development system, which we developed in Europe with a lot of research partners and companies together to build a complete new framework for compiler development. And I hope you understand what a compiler is. And that's quite unique for a small company to be able to do that and get a worldwide position. And through that, and also the other technology, we've reached billions of pros worldwide while nobody knows us. That's the fun. It's like Intel inside, but we don't explain that to everybody. So sometimes it's good to also in the Netherlands to promote this a little bit. So that's what I'm here today as well. What I will go directly into is in processors, because that's related to compilers, and it's also the core of IoT. So it's partly compilers, but it's also processors that are actually the foundation of IoT. And of course, IoT, I don't want to try to explain what it is and what my feeling of the definition is, but what I see as the ground rule of why IoT is there now and will come is actually from the chip level. The fact that actually, in my opinion, if I talk to all these chip vendors, the fact that you can produce now communication chips that actually are so cheap that you can actually get it in any product is actually one of the drivers for the IoT market. You can talk about cloud computing and all kind of things around IoT. I will focus on that area. That has enabled it, and that's where we see some trends and things that will be coming. Also things that are stopping it, by the way. But we've been working with a lot of processors, so this is actually, you see real processors here that I got in a kind of map from a conference a long time ago.
I noticed on there there's no ARM processor. Is there a reason for that?
Well, I don't know. Actually, the fun is that this is from the microprocessor report that actually is about microprocessors. That was a kind of established organization a long time ago. And they organized the microprocessor forum every year in the US, in the Silicon Valley. And we went there because you could meet all the CTOs of all the chip vendors easily. They were all there presenting their newest, latest chip. And actually the fun is they had a kind of binder that you got, and they asked the speakers or the supporters of the organization to provide chips that they could put in the binder to give you. So this is a small one. My CEO has one with fully equipped with all these things. So they were the broken chips that didn't work. And ARM probably didn't sponsor it. That's probably the reason. They were there at the time, but they didn't sponsor it. And this is only just some few chips. Actually, the other part where I will say quite some things about in the presentation is about compilers. And I all know what a compiler is. I hope somebody has developed a compiler one day. Did somebody develop compilers? No one? I can freely talk tonight. I can tell you compilers are a pain. Actually, they are very complex products, hard to get complete, hard to get right, and there's always challenges. I've been in the compiler world for a long time, and it's not a funny world, because you only talk to people about compilers when they were wrong. When they're working okay, you don't hear them. It's not, it's like it's there. And there's a lot of issues around it. So if you are a compiler engineer, and I've met a lot of them in the world, once you've done that and able to do that, you can do anything else in programming. It's that simple. And I don't know if you see the picture here, but this is the one we use. The dragons, actually, the Dragon book is a famous book originally where compilers are explained. So we compare compilers with dragons to fight. So you see this one knight trying to fight a dragon who thinks he's in the cave, but actually it's bigger than that. That's what compiler people find out. And I found it out myself as well. It's not easy, neither from the technology perspective and neither from the business perspective. So we had to work hard to get a position there. So I explained already a bit about one of our technologies that we have been able to develop in Europe, the COSY compiler development system. And actually, it's interesting because this plays a role in IoT quite heavily, because this technology is used by a lot of these chip vendors to build compilers for their deeply embedded processors, which are also used in IoT for communication. And compilers are not easy, I mentioned already. We've been able, with the work of support of CWI and INRIA and other partners, to build a technology that's very modular and much better than the open source ones. And it's used a lot, but it's hard to explain this, and I will not try tonight. But the software engineering aspects, for example, the modularity of the system with 1AR, different front ends like C and C++, and actually one of the things to automatically generate backends for new processors are features actually that made this technology be used by many chip vendors. And actually, it's funny, people sometimes processors are hard to define and tools as well. But using this, for example, the Erasmus University in Rotterdam, the medical group, they develop processors with the tools in 1 week for brain plant implementations. It's quite unique. So this will give you some background. If people want to know more, I can explain later more about this. And I've been looking into the kitchen with our teams in all these chip vendors, what they're doing on chips and development and SoCs from our compiler technology perspective, and usually long time before the products are on the market. So you're talking about today like LTE that you have in your pocket, but LTE was actually, it took a long time to develop because it's a lot of processing power in the telephone. that actually you need processors that actually run that efficiently, not only from a real-time perspective, but also from a battery perspective. So some companies, it took it 4 to 6 years before they had a solution that really was efficient enough, and our technology played a role. So you look very early into the kitchens. So what we're looking at today in the kitchens of these companies, I hardly can explain much under NDA, or actually only under NDA, but we can take some derivations from that, what will happen in the future from there. So this is a kind of chip vendors that most people don't even know, but they have chips that are produced in billions worldwide for all kinds of devices, and most of them are even in your pocket there. An area that I like to mention, I'm just covering from all kind of different areas into the IoT domain, and I just took some pictures of things that I wanted to explain, because we have horizontal technology that's used in all kind of domains. And it's interesting, if you talk to all these companies, you see the different way of developing software. And I don't know where you guys work in, it's either consumer or maybe automotive if you're in the south of the Netherlands in the Helmond area, or maybe in avionics. Fokker is not there anymore, but there's still companies working in that, or in space. They have different ways of developing software, and we come at it, and sometimes I'm frightened when I see that, the differences in this world, how they work and approach software. And that's also one of the things that's blocking IoT heavily in terms of full integrated solutions. Because if you look at, let's take the positive side, if you look at a car, like a European car, you're there driving in it, and you're there even switching on some things to drive automatically as far as it can go. You trust the car. It's been tested heavily. I talked to one of the Volvo people some time ago, and if you see what they do on the testing area, and related to safety for cars, which is an obligation, it's immense. And actually, if you look at airplanes, everybody gets into an airplane easily, but the systems behind it are really extensive in order to test it. Not from the compiler perspective, by the way. They don't trust compilers because they are, they can introduce bugs and things like that. So they do the certification on assembly level. But every domain does it differently. The automotive have their own standards, like ISO 26262 to do safety. Aviation have their own standards. And then you see, on the left side, you see here a Snapdragon with many processors from Qualcomm. The way that's tested is also heavily, because if it fails, they have a project like 100 million or 200 million that they lose. You see what happens at Samsung when something breaks. So they do the testing properly. And then you get into other domains like the Nest. It's Google, so you think it works, but 2 weeks ago I heard on a cybersecurity conference that they put some teams on hacking these devices, and they all won. The one was the fastest, the other one had the most unique idea to hack it, but they all hacked it. And this is a device you use at home. It's not safety critical, but it's like, we all know what the problem is. Even Google can't get it right. And then you look at even, like GCC, everybody maybe works with GCC. We have a group, we've been building, actually our philosophy, and that is designing things right from the start, spending some more time and money up front, and then you win in that in the next 20 years, because software is used much longer than hardware. And like GCC is built the way it's built, and it's actually we have built testing vehicles for compilers as well. We actually set up a separate company doing that, and they test GCC compilers. And most companies don't even test their GCC compilers properly. We have seen ugly stories there that you wonder why the compiler is translating all the code into the hardware, and why don't you test the compiler? The automotive, they do that, they have to do that. They don't trust it, they don't trust the compiler. However, how good you test it, you need to certify it. So they do the assembly level kind of certification. But most people use compilers and they can introduce bugs. And there are well-known bugs in there as well. And then you get to the funny stories of IoT. And I don't know if I don't want to say anything about Barbie, but there's a big stories in the world about the speaking dolls. I don't know if you've seen it or heard it. It was even on television last week, where people hack these Barbies, kind of IoT devices. It has communication, it's connected to the internet, so they talk and they send the information of the speech to a server, and that's actually interpreted, and then a message is sent back, and they speak to the children. So there's Dutch people who hack that and actually give another voice or give other words or do whatever with it. It's very funny, but nobody checked or tested it. The whole cloud is open. It's funny. People didn't even think. So a real disaster has to happen before this is really applicable in other domains. But it's funny to see how this works in the world. So IoT is not there for a long time, in my opinion. But just from my experience, it's sometimes very good to look at other horizontal or other vertical markets, how they do it and what their way is, because you learn from that. And it's not always the right way, but at least they get to a solution. So I mentioned security is the killer for IoT. You know, you see the examples, even cars are broken in while they're driving. Yesterday was a story about even 4G could be tapped. If you force it to go to 2G, you can actually break in and get all the data out of it. If that happens, you know, all the hardware you can throw away. The last week DDoS attack, it's very recent, you know, the IoT network was used. I don't know which network, I didn't find out yet which one it was, but it's funny to hear about that. And what's next? And my prediction is the real disasters will happen. It will take indeed years before this is right for many products. And also related, why is that? Why is that all not right? And we've learned from compiler development where we have to compete from a technology that we have that we license worldwide. For example, with open source like GCC and LVM, we see that, you know, sometimes people say, you know, it's free, so let's use it. It's free, so it's good, so we use it. And with a lot of these devices in IoT, you see that people just take some software and they use it. They use it for the website, for libraries and things in the hardware, but they have no people who understand it and no people to check and maintain it. And the integration, which is the real issue on the vertical, is critical. So they have to do that properly, and they can't do that. So that's why you continuously see that happening, that people take open source while they better develop it themselves, doing it right and have control. The different licenses, I'm not sure if people are interested in that to know, but there's different licenses also for open source which are used politically and strategically by large companies to actually control what's happening in the world. And we've seen and been in the middle of religious wars in licensing for these kind of technologies, also for IoT. And that's happening as well, and I will say a little bit later about that. What we feel is very important is standardization of all kind of effects. And as I mentioned, Unix was standardized. Partly I was involved myself personally. And that standard is 30 years old, but it's still used today. All your devices that you have are Unix and are POSIX compliant, so it's still used today. And C is a funny language. I hate it. From a compiler perspective, users hate it from a C perspective. We have all kind of checkers. The users have all kind of checkers to check, do you do it right? It's funny, why does a language like C get so popular? It was originally only designed as a low-level language for Unix to implement it on hardware. I don't know, but that's one of the questions I have in the world, why people use that still today. It's legacy probably, but there's an official C standard, there's an official C++ standard, it's evolving. One of our employees is actually involved in the standardization of that. He's in the committees of the various languages and involved in that heavily. It's also sometimes interesting fights. But then you see all kind of deviations, and that's also funny to see. Actually, we're part of that problem. You see Misra C has been developed by it's officially motor, yeah, that's for the automotive. It's actually Motor Industry Software Reliability Association. They actually defined a subset of C for the automotive in order to be able to control the software, check the software better, that there's no flaws and no problems in there. It's a pain for everybody because the compilers have to adhere to it, you have to do the testing, you have to do the certification, so it's a lot of work. But for the automotive, that's okay. And then there's all kind of other things even for the airplane industry, they have separate extensions. Then you have the GNU extensions, they're just like the one, oh, we like this, so we put it in and it works for me, so it's okay, and it gets into the tree. And those ones are the worst, because people start using it, they create legacy, and they're conflicting with each other. I mean, the front-end builders, like the C++ front-end builders, they have the biggest problems in getting this right, and compiler builders as well. And now they try to standardize it in ISO, which doesn't work because it's not a good thing. But it creates a lot of issues in the programming for portability aspects, because if you have a GCC compiler, you use those features, you cannot use a Greenhouse compiler or an IR compiler or another compiler. And that's one of the troubles we see also for the application workers to get involved. And then we are ourselves involved, we've been involved PARC for parallel systems, for transputers originally, to extend C for expressing parallelism, which has been quite popular at the time. And actually today, maybe nobody knows here, but embedded C is a language extension to C, which is ratified by ISO in a technical report. And that's actually coming from us originally. When we're doing compilers for DSPs, for signal processing, we worked together and defined an extension that we call DSP-C. And then we gave it to ISO to standardize. It took 5-6 years. And now it's an official part of it. And it's used heavily in detailed communication areas where they program DSPs, like in the Ericssons and those kind of companies. And it's a way to describe additional features for embedded, like memory spaces, fixed point data types that are not part of C. So you have them in C at a portable level. And most people, they use intrinsics for that, but it's not portable. So if you have a million-line intrinsics code C for your LTE implementation, you have to rewrite it for the next chip with the other compiler, which some companies have costed millions. And then, I think I saw in the previous, one of the previous meetups, there was a presentation about Objective-C. That's Apple's extension. Great, but be careful using it because you can't use it on other systems easily. Just a warning. It costs millions. I mean, from a portability aspect, I sometimes take the example, I think my salary calculation is still done in a COBOL program from the 80s, running on a virtual machine, which is actually mimicking a mainframe on a Linux box. And you may be laughing, but that's still reality for a lot of software. It runs for 20, 30 years. And even our software that we developed right is still used today of 30 years ago. We worked something for ESA, European Space Agency, which is part of the robot arm, the simulation thing. It was developed in 1986 or something like that. It's already until 90, and it's still not in space. All the companies that developed it, they are not there anymore. We're the only one that's still there. And sometimes things have a long life, particularly in software. And I mentioned already some of the engineering mistakes that we've seen. It's always, for us, an advice as well to groups of software development, think before you start developing also about the tools you use, the languages that you support or want to use. There are so many examples that we've seen, like intrinsics, which is a part of a C that you can use to do fixed point and other calculations. We've seen companies, TI have done that, and it's very good for TI because there's so much legacy, and the only way to get your code right is buying a TI processor and a TI compiler. You can't move it to an analog devices or another processor. So you get yourself into legacy that you can't refrain. So portability is a very important aspect. And once you've learned, then you've seen what you could have saved if you've done it properly and spent some more time at the beginning. There are tools nowadays as well. And the testing, I just heard in talking as well that sometimes today people spend more time on testing than on developing. If you develop or do things right, you don't need to test that much if you use the right tools. So that's why I still don't understand why C is still a language, but that's a side story. I mentioned already I've been growing from engineer to marketing and sales. In that sense, don't think too big about that. We are a group of very good engineers, and there was nobody doing sales, so I picked that role and I went for that. And actually the COSI compiler development system is an interesting story because we developed that in Europe. We built compilers ourselves, and then we were confirmed again that the compiler business is not easy. Everybody wants to get tools for free from the vendor, so it's not an easy business to sell tools. So we switched to a different business model like ASML to actually, instead of building chips, we don't build compilers, but we license the technology to other companies to build compilers. And it was a brilliant choice, and now I've been doing business development, that's between quotes, by just going around to the chip vendors and with our team, explaining them how good we were on that technology side, and we've been able to get hundreds of licenses worldwide with our technology. And by flying around the world, like crazy, I can't believe that I've done that in the past. But so these are pictures of Mount Fuji, different ones, flying on the one side, flying on the other side, going there, walking up. And you see the planes and all the big buildings. And Shanghai is one of these interesting cities. I don't know if you've been there, but you come there. If you come there 3 times in a year, every time you come, you see new buildings around you. It's like crazy. So it's enormously interesting what I've been able to learn in cultures, in ways, in working with other people, and meeting all these teams where you wondered, how can we ever work with them, like in Japan? And it worked out very well because you talk the compiler language and then it's okay. to give you one idea. But we've been growing that just by doing it. Just no nonsense, Dutch, don't worry, just go for it. And then don't make a plan, but just go for it. So that's how we won them one by one in a small team, just 15 people doing all of this. And what we also learned, that's a more completely different subject, but it's more, we're here in the Netherlands now. We have a Dutch country, we have politics here, we have economics, we have technical things here, we're very open. And then we as a technology company, we come in other parts of the world, and sometimes it's different. You think you know how to get into Korea, so you work with the institutes, and then you think you get Samsung as a customer. Well, it's not that easy. They think nationally, China is even, they think as a country, US as well. And Europe is very open, even US companies can participate in European R&D. So it's very different, you have to learn all of this. So I've tried to learn. I've been trying to do projects with Japan, with top researchers in Japan, to do joint projects, and it worked fine, but we never got it granted because we're a foreign company, and that's hard to get subsidy and give that to a foreign company. So we've tried that, and you get a lot of cultural issues around it. That's for me fun. That's why I like to do this. Like how do you deal with a Japanese guy? He's silent, so you have to be careful. And in the US, you have to raise your voice to get the attention. As an idea, as you're one guy, you travel around. And then the fun is if you have a Japanese guy in the US, how do you approach him? It always fails because you don't take the Japanese way, then he doesn't want to listen, and if you do it the US way, he is insulted that you shout. So it's hard, but it's fun. So that's the thing I've learned in the many years. And yeah, you see I put a cross here. The funny thing is in Europe we don't have these fights, but the national fight. But if you look, for example, in the telecom business, like the Huawei's and the US, it's like how they work together. Huawei doesn't sell products in the US, if you realize. They're banned by the government. And in China, you can't use Facebook, and so US products are not used as well. And we don't realize that, but there's a big impact of that. And we are open, and everything comes in. And sometimes you don't realize that in that sense, we had a disadvantage by being in the Netherlands, because competition is easy to get into here. For us, the difficult customers are in the Netherlands, because they can choose anything. And sometimes the US are interesting because it's sounding better or something like that. So we've learned a lot, and this cross is not for that. Be careful in this technology side. And that's also related to IoT, which is a story tonight. In the prediction later, maybe I'll mention that, but I'm worried that nobody gets it right in terms of the whole vertical for IoT. So some companies like Apple came into the mobile business. There will be either one company coming up in that area, or one of the existing companies will grab the whole business. And I hope it will be a European company, but I'm doubtful about it. So this is the end of the overall part from a cozy perspective, the compiler perspective on IoT. I've covered some of the issues, not everything, and I can go into more detail if you like, and if time is there, but that's restricted tonight. So I wanted to actually switch now to just a few thoughts about IoT and the future, which was mentioned. And of course, Gartner and other companies are doing very good work in predicting the trends and being wrong always. Afterwards, they never look afterwards back, how did they do in the past? So you should ask them when they give a presentation, what was the sheet 10 years ago and is it correct? But some things are very correct. You see now virtual reality is now really getting there. It's getting there. You see nice products and they work. Augmented reality as well. So you see all these trends. Actually, I should explain maybe if not everybody knows this, but this is I call it the hype curve. So it actually, you have something new, like 3D printing was there, it's now reality. And actually it gets overhyped, everybody's talking about it. And then at a certain stage you get the peak of inflated expectations, and it's the whole market, everybody jumps on it. And then suddenly people find out that, it has to work and it has to be real, and it's not for everything. So then the real business starts, and then it gets into the real commodity in the end. And funny, we think that we have IoT today, and we predicted already years ago, it will take a long time before chips are in your clothes and in all the things that communicate with everybody. It will take time because the chips are not that cheap yet. They will get cheaper, and that's the driving factor. So you see IoT is still higher, IoT platform actually, to have a platform doing that. It's still getting into the peak factor. So then you will see that nobody talks about IoT anymore here. They will talk about real products and then it goes to market. So this is about the IoT kind of prediction from Gartner that it's still coming. And everybody jumps on it. And business plans, research plans, too late, but everybody jumps on it while you should talk about real products that you can sell into the market. I think I should mention that later. Yeah, that's on the vertical integration. Actually, that's one of the things. Maybe I can explain it like what we miss here, or most if you're developing, like TomTom is an example, Philips is an example. If you look at integration of these kind of things for IoT, IoT is like you have an integration of many aspects. You have to have a device, so it's typically a chip, all software on that, but then you need communication, you need some cloud interface, and you need a lot of different parameters to get a complete IoT solution for a product that is worldwide. And if you look at from the semiconductor industry, it's hard. They don't control clouds. They don't have an idea about how to do security software or something like that. So it's very hard for them to do the whole vertical. And on the other hand, the market for washing machines or other devices that could have this integrated very well, they don't have any idea about chip design and about security and about networking. So everybody is doing their own solution, and that's why it's such a chaos. And actually, there's nobody doing the whole vertical. Well, for example, IBM is doing a platform for IoT, which is great. Of course, they can do the whole thing, but they may be one of the winners. But we have to be careful. Maybe at certain sites there will be a company starting up and doing the whole thing, and doing it properly, maybe. But that's a kind of speculative thing. So you have to always be careful if you do something in that area, where am I in this space? Because I've learned personally from US people, if this elephant comes somewhere, don't be on that position where it's putting its feet. Don't be there. So that's a kind of IoT thing I see from a technology perspective, that there's no real one player defining the rules. While in other markets you see at a certain stage, you see maturity, and then you see one player. So I expect, actually that's the relation to the previous picture, I expect sometimes here, there you see the serious players in IoT coming up. And in my idea, to give you an idea, for example, BlackBerry is a company that, I'm just from a free personal opinion, I know BlackBerry, they were these phones, everybody, BlackBerry now is dead and it's, couldn't make the phone. Be careful. BlackBerry, their real success story was security on the phone, the security thing, to control that. And they're reviving actually in that space. They're coming with the whole software solution for security on that. So they could be the security solution for IoT. Could be. I mean, it's also depending on how other players work there. But that's a very interesting player field that you see. And I don't know who it will be, but there will be a lot of coming in, shakeouts and everything, and mergers and acquisition like you see now in the semiconductor industry. But it's an interesting challenge because it's a whole field. In automotive, is not necessary, because you have car manufacturers doing the whole thing, and they're just assemblers. They just take products and integrate it to one device. With IoT, you don't see that yet. And the Nest failed, by the way. So then, as I was asked about speculative things on IoT, what's after IoT? Well, it still takes a long time before it's there. But if you look at IoT from the perspective that I looked at it from chips, actually that become cheaper and cheaper and cheaper. So that's why IoT can be enabled, that you can have the old dream was to have a kind of chip that you put on your milk box that you buy in the supermarket, warning you that it's over time, depending on the temperature, time factors and things like that. That's all based on Moore's law, and I hate to use Moore's law because everybody uses it in the presentation, but effectively that's the core why IoT will become successful, of the price of the chip. And it's every 18 months, chips are 2 times faster, 2 times cheaper, and use 2 times less energy, kind of directions. It's not that bold, but over time, if you look like Ace Unix, when I started at the company, I was porting Unix on systems in Europe and doing product management. We had 64 kilobytes of RAM for a full Unix implementation. not with the network layer stacks, but they were coming later on it. And it was just one processor, 10 megahertz. If you look at today, you have 4 gigabyte easily, and you have 3 gigahertz, even more. It's a multi-core, so 4, 8, 16, whatever cores you get. But now think about what if this trend follows, and it won't, but it grows. And in 10, 15 years, you have 40 gigabyte on just a chip, and you have 1,000 processors. They exist already, chips with 1,000 processors, but it will continue. And you work at 6 gigahertz. What will you do with it? That's what we wanted 20 years ago as well. It will be used. It's like this space. When you have it, you fill it. There's communication, networking. You have 4G. You use it. You fill it. So it will be there. Will it be going? I don't know. But if you look at what ASML is doing in the Netherlands, it's great. They just say next generation should be this, that, and that. We don't know how we get there, but this is how it should be. And then they start working with all the fields to get there. And I think some things like this will happen more quicker than you think. So from a technology perspective, this is the driving next generations. And this will not help IoT. It will help other things to be able to be done. Quantum computing is one of these hype factors. It's also on the Gartner hype graph. It's funny that if the expectations are so big that people put so much money in it, then I'm wondering, are we sure? Minister Kamp wants to put $1 billion in it in Europe. I wonder, is he sure? Because the experts say, I'm not sure if and when it will be able, if we succeed. And of course, you look at it from the ASML perspective, it will succeed. But if you need machine learning and AI to control a machine that's not working, correctly, I wonder, it's hard. But it may come. So it will change radically a lot of things we have, and it will change. Actually, the fun for IoT is if this happens, you can throw away all your hardware because the whole security issue is gone, and people can still look in everything what's happening. So that will give a big shift. So this is from a technology perspective, that how I look at it and how things may change. Underlying from a technology. From the compiler perspective, by the way, in this area, the funny thing is there's not so much. The compiler, it's a funny observation that one person at IBM made one day, that if you look at the history of compilers, you see all these chip changes, you see everything changing, and the compiler effectively today and 30 years ago, same techniques. People build a new open source thing, they start from scratch and they build all the things we built in the past 30 years again, with all the mistakes coming back again. And not much has changed. It's more code, more optimizations running in parallel, and they get more out of it, but it's always like, it's not like a factor 2, it's not like a factor 10 or a factor 100, it's like 30% or 40% they get off. And effectively, funny is that, to explain Moore's law, there was one guy at IBM said, we built a compiler 35 years ago, and it was so much code size, and it took like a minute to compile a certain piece of code. If you look at today, you have a huge compiler. If you compile the same program with the same compiler on the hardware of today, it's still running a second. In spite of all the advantages, it's funny to see that. So compilers are not that innovative, and not many people spend enough money on that to do the breakthroughs, because nobody wants to invest in that. But particularly for IoT, we are working on next generations with the software as well, where security and other things are built in. And that's, we believe, the drivers for these kind of new developments. So let's go to the speculative part. Just some ideas. Don't quote me on it, but maybe in 10 years I'm right. One of the things we wanted for a long time, from a compiler perspective, is we always stuck to this. It's funny that we're compiler experts, so we have to port a compiler on a certain architecture with instruction sets and things like that. And the fun is in the 15, 20 years that I've been working in that area, you come at a chip vendor and they present, we have this beautiful architecture, we need a compiler. And then we start looking at the architecture and say, well, interesting architecture, yeah, very good. Why did you do it like this? Yeah, to get it very fast. But for the compiler, it's a pain. We have to do a year more work to get the compiler right because of this stupid feature. Yeah, okay, but that's okay. But we can't change the hardware, it's there already, So you get this funny discussion that it's like bottom up. So it's good to look at the other way around. And what we've been looking at from a compiler perspective is like, when is the flexible hardware coming? That you can just, nowadays people spend, like 100 million to build an SoC. And it has to ship in billions in order to get successful. Otherwise it's not worth the money to do it for a new telephone.
FPGAs.
Yes, FPGAs. I know personally the FPGA companies and their CTOs. Have you ever programmed an FPGA?
That's cool, yes.
It's cool. It's a pain. You can't use C. Well, you can't use regular, you have to really get into the hardware to do that. But you're right, FPGAs are flexible, but not flexible enough to say I can do anything on the hardware, to actually build flexible hardware that you can actually, as a user, like 3D printing, now you have to wait until some device comes in. I think one of the holy grails for that is that you can actually build, you should just have your software. You build, actually, instead of bottom up, like the hardware vendors define this new architecture, you program it and you build a solution. The holy grail, you come with your software or algorithm, you say this is my algorithm, this is my software, and then build the best hardware for it that runs with this power and this whatever, build it for me, generate it for me. And our tools have been used in those spaces for selected areas, but this is what, and I don't know if you know the Mapper company in Delft, that's one of the companies I like, because they have this technology where you can actually make small runs of chips to really build your own chip. If that goes through, then I guarantee that there will be a revolution, maybe also for IoT, because you can quickly build your own small volumes, not 100, I mean, you don't have to buy 1 million chips, you can just say, well, I need 1,000 to do this prototyping. For small companies, all the kind of startups can do things, also building hardware, because that's limiting them now. I mean, Qualcomm is buying NXP. You see the whole semiconductor world, ARM is bought by a Japanese company called SoftBank. Who knew SoftBank? It's crazy what's happening there, but it's all because the cost is rising. So we need a revolutionary technique to actually break in and change that rule and get small companies again in the domain. So this is one. I'm not sure who will do it. Mapper is an example, but we're waiting for it. I'm not a hardware engineer, but so this is one. Second, it's also on the list, this is also on the list, like the neural networks and the chips with neural functions and things like that, but I think it will go much further beyond, like sensors and everything that will be built from a chip level. So the chip is very good, I mean, people get it very small. If you can integrate in the chip production all kind of other functions for sensors, and it's now like radar you can put on there, and you can put other small sensors in there, but really put more power there, and if it can be produced cheap, then you get an enormous flow. And I have a Japanese friend actually who is a kind of innovator, and he likes to do new things. So, in Japan, there was one day, there was a kind of subway attack with a gas. I forgot the name of the gas, but a lot of people died and there was a lot of issue. So it's in the minds of Japanese, we have to fix that. So he actually set up a special startup company there to actually build a chip with a sensor to actually do ppm measurements on molecules. That can be programmed, actually, that the government, if that works, the government can program, hey, we have a tech here or there, program all the phones that have the chip, and then you can detect this kind of gas everywhere. It's that kind of IoT-related things that, if you have that, it will be quite a big thing if it gets cheap enough as well. And today, funny enough, there was an article when I had this presentation already about Harvard having a kind of heart function on a chip that I built on top of bio kind of heart. I don't know how they did it, but it's like something bio as well, that you can actually generate some bio stuff that you can combine with a chip. And from our perspective, from actually my angle that I give this presentation, if you sometimes, like I learned here at the start of bootcamp here, sometimes every year you have to retract you from 5 or 10 days and think about what you're doing in the future. If you do that about the way we are programming, like C, C++, PHP, well, mention all these languages, if you really look at it, that's a pain. What are you doing? You need 1,000 tools around it to check if you did your right things, if you programmed right, if you didn't make a mistake with your array pointers and whatever. All that stuff, I wonder, why are we using C? Why are we using C++? Why are we using this language? Shouldn't we do it completely differently and take some other languages? And I can tell you, We've tried from a compiler perspective and a language perspective many times. We had Algol 60, Algol 68, Ada, a lot of good languages, didn't make it. And where we ended up with languages that are poor and awful to use, but it's like we follow a hype and a trend and then we keep following it. Why is there no revolution under the programmers? We need something better, because then we can invest in making better compilers as well for some other things. So I think this is an area, a software programming revolution that should come one day to change this mistaken programming that we can't even use it for aviation, but confirm on assembly level that a program works. Come on, you should have higher level descriptions. So why don't we use, and that's my idea, why don't we use all these new techniques that we have, that we now put in machine learning, AI, speech recognition, all that stuff. Why don't we use that to actually define a new technique where my mother can program something that she wants. Just say like, I want this machine, or the washing machine to do this and that, after that and it works. Is that possible? I don't know. But why is nobody, maybe people are doing that, but we need a kind of revolution and some higher level idea to do that, in my personal opinion. So that's what I want to give to you as a kind of idea from this, in order also to be able to program IoT, because it's such a mess. Everywhere. If you see this Barbie or these dolls that are sold, and if you see all these products and you listen to the cybersecurity people, what goes wrong everywhere, wow. And I can imagine, I've been a Unix expert, so in the old days we ported Unix, and we know all the details. We have changed complete Unix implementation, everything to get it right and get all the bugs out. But I know there were many bugs in SED and all these tools, there were many bugs in there. Are they fixed now? No way. It's not built for security or things. And this week I had to hack into our router because it didn't do full duplex with some other router. So I used some command. It's just a Linux system. It's just a Linux system. Okay, let me check. And you can just see the vulnerabilities because there's all kind of software. And you wonder, why is it here? It's not necessary, but it's all there. And it's, on the one hand, it's easy because you can use Hadoop and all kind of things to see what's happening. On the other hand, it's scaring. Why do I need 4 gigabyte on a router while 64 kilobyte is probably enough? But anyway, we should automate these things. That's my opinion. And the last one from an IoT perspective is like, if this goes on, all these issues on software, maybe there will be a law one day from government, we should do things right. I'm not sure, but hopefully it will. So this is the kind of speculative part that I want to put last in order to give you some ideas from my angle and our technology and our small company in the Netherlands to do things in the world. We're working today on next generations and in different areas. We also changed our business model in that area. So I'm interested to talk to people about what they're doing in areas to find innovative people that are working on next generations that compete with the big guys all over the world. Because that's our drive. We've done that in the past successfully as a small company, developing a technology and be successful worldwide. It's not easy, but it's fun. It's great fun.
What do you mean by a software development law?
Well, it's more like if you see what's going wrong, if you look at automotive and you see all the mistakes you see in the way people are programming, I don't know if there are rules in companies if you look at the space industry, for example, every line you program is being checked and checked and checked before it goes in. If you're in some countries and you see how routers are programmed or devices are programmed, you can't do that. Just take some open source, put it in, and it works, so it's fine, and put it on the market because we have a deadline for December and it's Christmas time, so get it on the market, and we fix it later if somebody complains. And that's the... It's the economy, yeah. So that's where you get lost if you do a mistake. And I wrote an article in Bits and Chips about this. I don't know if anybody reads Bits and Chips. I'm from a cultural perspective, I'm very keen on Dutch culture and the US culture, for example. And I found out recently why, I wonder why we always look at US things like a Tesla. It's like, oh, great, Tesla. It's like getting the news, it's a wonderful car and blah, blah, blah. And then Tesla comes with, oh, we have an autopilot. And then it's, oh, great, we all start driving in it. And the official organizations that check the car, they also, they say, yes, it's allowed to drive. Can you imagine what would happen if a German car would say the same? it would be killed in the Netherlands. Like, oh no, you can't drive an automatic car. Actually, we helped Daimler at the time to actually build a automatic driving car in 20, 30 years ago. But it couldn't get on the market because the chips were not fast enough and things like that. It wasn't cheap enough. But today, it's a cultural issue. And actually what I found out, it's also a law issue. In Europe, we are not allowed to drive a car on the road if it's not certified and tested well enough. You're not allowed to drive it because it's a law. In the US, and you see it exactly happening now. In the US, no worry, you just go. And if it fails, yeah, you pay $1 billion you get claims. And if it fails, then the government starts thinking, oh yeah, let's put a law in place in order to fix it. And that culture difference is enormous. And that helps actually, what I'm saying, maybe we need laws to actually to do some things. I don't say it will happen. It's just a thing, but it will, let's say it otherwise, laws is maybe the wrong word. I think there will be much more regulation in that sense, how devices and products are, nobody's looking at it. That's one of the problems. Also with compilers, when people buy a compiler or get a compiler, they don't ask, does it work? Is it tested? Is it certified? No, just you download it and you use it, but you don't ask these questions. And that's the same when you buy products, and that's why now in IoT, you see that the government has all kind of check labs in order to do these checks and warn for these kind of products, because nobody else is doing it. So the government has to step in order to protect us from all kind of malware and whatever that's coming in through this. But that's more, it's not that I say there should be a law, it's more like maybe regulation is something that will come in order to help us do it properly. So this is like, our picture in compiler area, you fight a dragon and yeah, sometimes somebody wins. It's not always the dragon, but sometimes he wins. Any questions or remarks or?
Are you already creating a compiler for the quantum computing?
Well, the answer is yes. Yes, the technology is used for certain parts within quantum computing, yes. That's one of the areas. Yeah. It's very intriguing, very interesting if you see that domain, but it's still very wild and going any direction and not sure if it will work. But and it's also fun, for quantum computing, everybody's looking at these bits and things like that. It's good if that starts working, but then how are we going to program it? And people are thinking about it, but there's no connection. What I'm looking for people is who make an integrated idea, like if that's going to work, we have to do the whole vertical. And who's controlling that and makes the money out of it later? And my prediction is it probably will be, an American company or a Chinese company who thinks about that from an innovator, and they take it all and they build the product. And we think only about the hardware, but the software is key in that, is key. So it's used there, yeah, but it's still in an early stage. And for us as a business side, it takes years before this is happening. Yeah. Other questions?
I heard some stories about compiler optimization techniques that actually save energy.
Yes.
Can you comment a little bit on that in the respect of Internet of Things?
Yes. Yes, that's one of the things where our technology also is used, where it's combined with chip design or processor design, because sometimes you have, like already in mobile devices, you have a battery and you have to save. So for LTE, for example, you have to do a lot of calculations to get all the antenna information right. So you have to, squeeze that down to the. So you have different techniques for that. So people use parallel processors that run at a lower speed, or switch things on and off, and all kind of techniques, and they forget about a compiler and what it can do. I'll give you a joke. If I go if I put my sales hat on, I go to Texas Instruments. I go to the CTO, and I tell him, you have this hardware. I have a trick, and I know a Dutch guy who's done not with TI but with other companies. I have a trick. I can change your VSDL code on the hardware, and I can save 30% of energy, or 20 or 30%. Give me $1 million. And he calculates on the back of his sheet, oh, here it is $1 million, because if you do that, he'll make, he knows what he earns. It works, 5 months later it works, he's happy, everybody happy, and then he comes back after 6 months, I'm back again. I have another trick. I can optimize the compiler to get another 20-30% on your code size, and resulting directly in performance or other. And then the guy thinks and says, no, I can't do that because it's software and it should be free. And I can't explain this to my management that I pay money to software things. And it's a bit exaggerated, but effectively nobody taking the really assets of a compiler, what it can do in that area. So we have dedicated customers, to give you an idea, that do that for chips that I can't talk to about today, but they have one guy doing the compiler, and they have one chip for audio, video, something, and they get every cycle out of the program for their, their whole stack of software, which is not, it used to be like 10K lines of code, which they could do in assembly, and now you're talking about hundred thousands of lines of code, up to millions of lines of code for an LTE subsystem. And they care, and they win with that. But they don't tell that to the outside world. But yes, you have techniques. We work with universities who build also these techniques, and our system is very modular. So one of the things we solved in compilers, if you're an expert in compilers, the challenges of a compiler is that you have hundreds of optimizations actually and changes in the compiler that you can apply. They're all written down, and you can build those. And in COSI you have all these techniques in separate engines, as we call them. And it's more like, how do you interact? Because some of them conflict. If you do a loop optimal, you get more code, which is not good for your code size, but it's good for the performance. So you have to make the trade-offs, and that's what we can do. We can make the trade-offs and plug in your own optimization to do that. So if you have a case, come on, but we need a business case. That's the problem. Research we do with universities. Yeah. No questions. I should tell you, when I'm in other countries, sometimes every country has its own rules, and sometimes it's very silent during the presentation. At the end, they start asking questions. And if you're in China, the presentation is half an hour, and the questions is 2 hours. Sometimes they keep asking. They want to know everything. It's funny. And in Japan, it takes a long time because they have to translate everything. But that's another joke. That's the other joke of somebody giving a presentation in Japan, and then at the end, people clapped and no questions, nothing. Then the next presenter came and he presented the whole story, and then a lot of claps and questions and things in Japanese. And then he asked, "What's happening? Why is he getting?" That was the translation of your talk. Yeah. Okay, thank you then.